video. This one is a little bit different. It's more for my preparation for my next interview. So the first interview, they asked one sort of procedural question and then another one which is more of a recursion question. So I feel like for the second interview and onwards, let me just check my, okay. So for the second interview and onwards, so second round onwards, I feel like they're probably not gonna do recursion slash depth first search as much. I mean, I'll still study it, but it's probably not my topmost priority. I'll probably do and focus on more like breadth first search techniques and also dynamic programming, the latter being a bit harder. BFS, I feel like I could sort of do in a bind. But dynamic programming, it's like I can solve some problems pretty easily, but some other problems are not that intuitive. In the previous two videos, I kind of talk about like these buying, selling stock problems. And so so in this video, I'm going to do something different because the video of me doing this took like an hour and 35 minutes. I don't think it's that educational to just watch me like not get the problem for an hour and a half. So in this video, instead, I'm just going to summarize what I tried to do and then talk about the actual solution I saw in the discussions and then how I might adjust my mental model thinking about these sorts of problems going forward. So let's take a look at what I did in a high level detail. Probably not going to go through too much code. But the prompt of the problem is it's just basically saying like, you want to be able to, given an array with k number of transactions, you want to maximize your profits. Where if you were to buy at one time, so the prices are in time order. So if you were buying one time and sell at another time, that's one transaction, and then your second transaction must be after you sold your first transaction. So for example, here the most optimal solution is that you'd buy at this time, which is price 2, sell at 6, buy again at 0, sell again at 3. And that's you're going to output 7 as your max profit in this array. Now, what I tried to do was something somewhat complicated. So I tried to basically have two loops. So one, the outer loop is the number of transactions, and the inner loop loops through these price checks. So my thinking was per transaction, I'm going to come up with like the best possible prices for the entire array. Like if I were to only do one transaction and then try to update that. It turns out this is particularly difficult because every time you update your array, so for example, here it'd be, if I had to do a first pass, like if k was 1, then I have like, 0, 0, 4, still like 4, 4, 4. Because, yeah, buying from 0 to 3 is still, you're still better off buying 2 and 6, for example. So you get like an array of like the optimal profits at each time where k equals 1. And then my thinking was, well, given that cumulative profit array, that's the most optimal for k equals 1, perhaps I can do something with that array and then just expand it for the k, like the second k. So like now that my price, I have this base price and then another array of the optimal pricing if k was 1, then perhaps I can combine those two pieces of information to do k equals 2. And then once I've kind of gotten another array, then I could do like k equals 3 and then kind of build up the array that way. Turns out that's quite hard because each time you update your your auxiliary array to say what is the most optimal thing, what's the most optimal profit per time. One thing that you do when you overwrite that array is you also overwrite any and all information of when you bought and sold the prices. So it's very hard. Like you can imagine k equals 75 and you have some array that says, well, up to k equals 74, I know what all the optimal prices are, but you have no way of keeping track, or no easy way of keeping track of like what are all the, like the past 74 transactions that you did was. So that made it pretty hard, and undoubtedly it's a cause of a lot of bugs. So the main error in thinking there is I think I should have not implemented it if it's like super duper complicated, and perhaps invested another like 15-20 minutes thinking there's something else. And in this case, the main error is, the main sort of where I went astray is that instead of the outer loop being k, you can actually have your inner loop be k, which is what the dynamic programming solution is here. So perhaps I can erase this because I believe I have memorized the answer. If not, I can just do it later. So as you can see, this is the entire the prompt in its entirety. So I guess a way that I guess one way I really should adjust my thinking to really gear towards DP problems is if you have to make a bunch of decisions on stuff. So for example, if k was 1, it's quite easy. You just maintain 2 pointers. And even k equals 1 is a sort of a dynamic programming problem, but we often don't think about it like that because we have most people have the solution somewhat memorized or ingrained in the back of their mind because it's more of a classical software interview question. Now, if you have k transactions, then it's like, well, I need to make a lot of decisions over time across the array to know if I should buy or sell. And there's some, optimal path problems and things of nature, more graph problems that I'll probably need to study more. That also lends itself to DP, where you can derive some information from some subset or like a smaller piece of information from a smaller problem that you solved earlier. So I was trying to do that in my original solution, but each step to solve like the next k is much, much harder. So it's like, well, how do I think about this problem in another way to restructure it? Well, one thing is instead of the outer loop bk, we can have the inner loop bk. And the reason for that is we're going to traverse, this 326503 over time. So what if we just solve it for 3, right? If we solve it for 3, it's basically 0. You return 0 because you can buy it, but you can't sell it. What about, and then so after you solve that, then you solve 3, 2, right? And then so for 3, 2, so I'm talking about iterating through over I, right? So, you just look at this, and then you look at these two. Well, to solve for 3, 2, then what we can do in the inner loop is actually solve for k. So if k was like 3 or 5 or 2 or whatever, then on this index, then you just say, okay, what was the most optimal thing that I've done in the previous time step, and then let me leverage that information to be able to see if I can actually do better if I were to inject a new piece of transaction here. So so I believe how they did it was they just initialize, so they have like a buy and sell array. So the prices is only up to 1,000, so we're guaranteed if we run the minimum against the buy vector and any pricing here, we'd always end up with the actual prices, right? So here we actually want the length of the, sorry, this is actually k plus 1, and then this will be an array of so the buy array now, instead of keeping the prices in memory, we're actually just going to keep track of the optimal buy price in memory. And same for sell. The sell, we want it to be 0. This way, if we're selling at any non-zero price, then the max of this sell and our sell price will always clip to the maximum profit, because we're trying to solve for maximum profit here. And the reason why this is 0 and not like negative 9 billion or whatever is because if we're not profitable, we have to return 0. I think that was either in the previous prompt or something like that. So 0 is kind of the lowest you can get. Okay, so now if I actually want to have the outer loop be I in range, I might just call this t for time actually, so 0 to the length of prices. And I should explain this k plus 1. So this k plus 1 means that if you have k, like let's say k was 3, then you can have 3 transactions, and this is for long because you need to account for the fact that I make 1, 2, 3, or 0 transactions. If you make 0 transactions, you return 0. So for time, in 0 and length of the prices, and then for you know, 1 and then k plus 1. You start at 1 instead of 0 because your 0 is sort of unneeded because there's no. So in dynamic programming, there's a lot of like look behind indices. So if you start k transaction or k equals 0, then there's like no negative 1th transaction. Instead, we'll just pretend we're going to start with the base case of we'll do 1 transaction, and can we do better if we did 1 transaction opposed to 0 transactions? And then the next iteration here would be like transaction equals 2, and transaction equals 2, we're just going to go ahead and compare our buy and sell prices, and then see if we did better in our if we can even do better with 2 transactions opposed to 1 transaction. So buy is min of so minimum of what we have here, which is best price, or it's the minimum of this, subtracted by so the cell in the time minus 1 says this was the best that this is transaction minus 1. The cell transaction minus 1 says, well, let's say k was 2, what is the best possible thing that we were able to do in a previous time frame? And so I guess the intuitive thing here is let's just say k equals 1, then we have this, and then basically this is just the so if k is 1, then this you can basically cancel this, right? And then it's just for time and range 0 to prices, and then this buy is just the minimum of itself or whatever the price is. Now adding this in, we're subtracting the sell price because for example, if we were able to sell something at 10, or a profit of 10 rather, then you can think of it as going from that point onwards. Let's say you made a profit of 10. Going from that point onwards, your cost basis is lowered by 10 because the 10 profit that you get is sort of like house money. So then the rest of the array looks like it costs 10 less. So now instead of just comparing the absolute price, you want to compare the price given the previous transaction, and the reason behind that is because if it's transaction instead of transaction minus 1, obviously then you have a choice to be able to buy another and then sell another. So that's that part. So what's the sell part look like? The sell is, well, did I do better in the previous transaction, or can I do better now, which is just going to be prices in time subtracted by this by transaction. So this says, well, if I am able to do, if I cannot do better, then, you know, obviously this guy is going to be less than this, and they'll just keep the previous transaction and then kind of propagate that over. If I can do better, meaning the current price and at this time subtracted by this adjusted by with a cost basis, then I can go ahead and say, okay, I'll go ahead and update this price now. Now, this price, let's say, I guess the sell is more like a profit, I guess, yeah. This really should, instead of sell, just maybe in your mind say profit. Yeah, okay, I'll just perhaps just do this actually. Is there any sell here? Yeah. So, yeah, so, anyway, so let's say we update our profit to some new and bigger profit. Then we kind of have more leeway to buy stuff, because then, like, if our profit was like 5 and then later on the price was, let's say, 100, then it's probably not that good, because we're not really doing better than our profit, or there's no chance to do it. Whereas if this profit was 5 and then let's say this was 0, then your buy price is like kind of at quote unquote -5, because later on, let's say this price was 0 and your previous profit was -5, right? You buy at 0 and then you'd sell at 1. Normally your profit is 0, 1 minus 0, right? Because you buy at 0, sell at 1. But now, because you actually accounted for this, your cost basis is subtracted by your previous 5 profit. So actually, it's like, you know, like your profit is going to be, you know, 1 minus -5, which is 6, right? Which makes sense, because if your previous profit was 5 and then you buy again at 0, sell at 1, then you're doing like 5 plus 1. So this is all that is. So as this gets updated, the next K will also update this profit, or the best that it could possibly do. Given it's one less transaction, and then you kind of update this. So yeah, and then once you're done with that, all you do is return your profit of K plus 1. So if you know, so even if you never buy after some iteration of transaction, or K, or however you want to call it, that information gets propagated, right? Because if this is always going to be much higher than this guy is held stable. And likewise, if you can't ever find a bigger profit, meaning this one's the maximum, then you'd always just propagate this tx minus 1 back to here. So yeah, and in here you would return K plus 1. Yeah. And I'm wondering if this needs to be -1. Yeah, this might be -1. Let's see. And let's just run this code. Let's see what happens. Okay. What did I get wrong? Let's just look at the answer. Oh, I see. You don't have to look back. Um, you don't have to look back because it's not going in time. Like this transaction is already updated. So for example, if you're at time equals 2 and you go from 2 to 3, when you're at 2, you already scan through all the Ks to get the optimal profit. So all I'm saying here is just saying like, well, at time equals to 3, I'm going to sweep through all the transactions again, but when I sweep through all the transactions, can I do better than this time over here? Like, is there anything worth buying, and is there anything worth selling? Whereas if you did profit of transaction minus 1, then instead of comparing like an action or like a decision over here versus a decision over here, you're actually comparing the same decision here, but with a previous K. But that's not what we want to compare, because we actually want to compare like the best bet we can do here, which is our max profit so far, and then compare that against whether or not it's worth it to buy something, which is going to look backwards for us in K already via this profit transaction minus 1 with the cost basis adjustment. So I see. Yeah, so this is definitely something I feel like there's two things. I just need to see a lot more of these hard Leetcode hard DP problems, so my mind can kind of intuitively think about it more. And yeah, I think that's like one of the main things. The other ones is, yeah, I kind of definitely need more intuition about how to come up with these formulas, because like even looking at the solution yesterday for a while, I still don't quite get it. So it's just, how do I make this very intuitive, very simple, and very easy to think about? And I don't really have the answer to that. But let me know, like, let me know in the comments, would you rather have had an hour and a half of me not coming up with a solution, or would you rather have me sort of explaining a high level mistake and then kind of walking through a solution? But yeah, this one should just work because I believe this is the answer, and then if I submit it, it should just work. Yeah. Anyway, this is a pretty good solution, but like looking at the answer at the back of a textbook, it's fairly difficult to get good if I'm not actually coming up with this myself. So that's kind of a trade-off, but then I also don't have that much time to study. So anyway, that's it for this one, and I'll see you in the next.